Hello, calculus class, and I'm happy to report that this is the last video of the midterm review. And after this, my work still isn't done. I have to post-process these videos and put them up on YouTube. But at least we're done making videos for today. So we have a graph of a piecewise function that we want to come up with what the function equation is. So remember, piecewise always look ominous because you have, like curly brackets, and then you have like, an equation, and then you have the domain um, for that. So let's just take this one step at a time, and let's just try to find the equation for that line. Remember, these are both linear, so they're really, really easy for us to write. I have y equals mx plus b. So I'm going to use that to help me out. I want to find the slope of this line. I use a nice simple approach for this. I'm just going to use kind of like a slope triangle here. And when I look at this equation, I see that I have a slope where the function goes up 4, it runs by 3. So the slope is going to be up 4 over 3. It's positive because the line is going upward. And then I look at the y-intercept, and that's what the b value is, and that's equal to 4. So I have my first equation. It's 4/3 x plus 4. Now I have to put a domain restriction in, so I put a little semicolon here, and I say, well, this function's only good for, um, we have to look at like the x values that it's good for. So it's good from x equals -3 to x equals 0. So, I'm going to do, using my inequalities, I'm going to say x has got to be greater than or equal to -3, and it's got to be less than or equal to 0. So that would be the domain for that first one. Now the next function, this one, is, again, I'm going to do a slope triangle. It's a linear equation, y equals mx plus b. So it looks like it goes up 2 for every 3 that it runs over. So the slope is going to be 2/3, and the b value is going to be equal to 0. Well, that's a nice easy equation. Y equals 2/3 x plus 0. So 2/3 x plus 0, but please don't put the 0 there. I'll understand what you mean when you don't put the 0 there. Semicolon. Now this one is, its domain is where x is going to be greater than 0. Notice it's not equal to, because it's an open circle, and then it's going to be equal to at the ends 3. So that's all there's to writing up a piecewise function. Usually they're linear. Now let's just say that when the people decide we're going to trick these kids and we're going to put in a real difficult function, and maybe we'll put in another part like maybe open circle at 5 and it goes over to 6, horizontal line, it does that. Well, this line has a slope of 0 because it doesn't rise or fall, and its y-intercept would be at 5. So, yep, you can do this one again. If I had to add in, I'll add it in red. It's not really on your review sheet, but this one would be just plain old 5, and that would be defined between 3 with an open circle, so an open to equal, and it goes up to 5. So I gave you a little, oh, no, it goes up to 6. My bad, I don't want to confuse anybody. So in case they gave you 3 parts, you would just add the third part in. Remember, when you construct them, be organized. Your first function should be your leftmost. Your second function should be, if you have 3, the middle. And your third function should be the right. And if you have a fourth, that should be the next one to the right, and so on. So hopefully this video has helped you refresh your memory with how easy and fun it is to draw piecewise functions. I'm looking forward to hearing your comments on the videos or this video, and hopefully we get to do some good quality practice in class this week before we have our midterms.